My name is Michael and welcome to a new GTK tutorial. Today we are going to move on and it is time to learn a new container. It is the second most used container. I'm not sure if it's the second or it's the first one because it is quite a big job between GTK Grid and the GTK box, the container which I'm going to introduce you right now. But anyway, from my opinion, myself, I am using GTK Grid. I'm done with GTK Box. There are quite some few difference where you probably want to use GTK Box, but it is almost up to you if you are going to use it. Anyway, in GTK 4 they dropped so many things because they changed so much about how the GTK concept was before, and those many changes which they come, the GTK box has suffered a lot of changes, and now basically in the GTK 4 I'm not really sure that there is something special about GTK box using it instead of a GTK Grid. Anyway, this is not the case for us to talk right now, and it is not the object of our tutorial to talk about those differences and between the releases. Anyway, like I said, the widget which I'm going to introduce you today, it is a widget called GTK Box. GTK Box is a container for packing widgets in a single row or column. In other words, we have a big description here which says the GTK Box widget arranges child widgets into a single row or column, depending upon the value of its orientation property, which we have it. And of course, within the other dimension, all children are allocated in the same size. So of course, the horizontal align or vertical align property can be used on the children to influence their allocation, things which you will need to done in GTK 4. Here are optional. Anyway, the GTK box uses a notation or packing. Packing refers to adding widgets with reference to a particular position in a GTK container. For GTK box, there are two reference positions, to start and the end of the box. For a vertical GTK box, the start is defined as the top of the box and the end is defined as the bottom. And the same thing goes from the horizontal, where it starts from the left and goes to the right, wherever. Anyway, the object here, as you can see, it implements a lot of other widgets. There are some of them which they are out. For example, GTK button box, which I saw a lot of people they use it. It's out, and whatever. Okay, that being said, let us check how it looks like. Before we move, as you can see, at this point we have I have a program which has a window and has a frame inside it with the name GTK Box. Let me compile it and run it for you, and it looks like this one. Just to be sure that you see, here is the frame which we are working. And at this point, what's very important for you is that if you don't know what a frame is, then just go back, watch my GTK frame playlist, and then come back here to be sure that you understand what the GTK frame does. Okay, so that being said, the first function, it will be called, of course, GTK Box New. And as you can see, it takes two arguments, the first, or parameters. The first one is the orientation, the second is the spacing. And for this we need to declare a widget. I'm going to do it right now. GTK widget box, and now we can point our box pointer to GTK Box New. The GTK orientation means vertical or horizontal. So basically it is the way how you decide when you create your box, and the spacing I will say 0. Now we can add it, container GTK container add. Of course we are going to put our box inside our window. Now if I compile it and run it, you won't see much difference, because it is just a container, nothing special. Of course, attempting to add a widget, yes, because, sorry, my bad, I told you that I'm using a frame, so basically we need to put the box inside the frame. Now it's clear. We have a window, we have a frame, we put the frame inside the window, we have a box, we put the box inside the frame. Now it should be clear at this point. Okay, now we have it. Now the next thing which you need to know is that, like I said, orientation, you have the vertical, which means the element is a vertical orientation from top to bottom, and the horizontal if you want to put the widget from left to right. So in other words, if I now change it to horizontal, basically you will still won't see any difference, but at least this is the way how you change the orientation. Create a box. Okay. Now the next thing which I'm going to do, I'm going to create a button, because the next function which we need to call, it is the packing, where you put packing at the start at the end. So for this we need a widget. So I'm going to create one right now, which means GTK widget the button, nothing special. Okay, so that being said, button, we're going to point to GTK button new with mnemonic. I don't know, let's say open or wherever. And of course, now because we have the button, we can call this function. This function, GTKBox pack start, means adds child to the box. Pack it with a reference to the start of the box, which means the child is packed after any other child packet with reference to the start of the box. At this point, because we decide to have a horizontal box, which means at this point when we call this function, basically we are packing the widgets from left to right, because it is an horizontal packing. So this means when we call this function right now, right here, and then we, as you can see, the first parameter will be the GTK box. And then we have three parameters. The second one will be the child, sorry, which is the button. And of course, the last three parameters or arguments which you need to pass are expand, true if the new child is to be given extra space allocated to the box. The extra space will be divided eventually between all children that use this option. Fill, which means true if space given to the child by the extended option is actually allocated to child, rather than just padding it. This parameter has no effect if expand is set to false. You will see that. A child is always allocated the full height of the horizontal GTK box and the full width of the vertical GTK box. This option affects the other dimension. Okay. And the padding, of course, the extra space in pixels to put between this child and its neighbors. So, which means if you pack left to right, horizontal, this means space from left to right and the left and right of child. Anyway, what exactly means? I'm going to use at this point false, false, and 0. So which means no expand, no fill, and no padding, 0. I'm going to compile it and run it and see what happens. Now, as you can see, the place which takes, it is right here, it stays on the left. I want to show you something because here it is quite complicated and I don't want to create a big program just to be 100% that you understand in this example. So I already have something for you, which is right here. Let me show you something. Imagine the same program which you showed in the you've seen it before when I created the button I put in the box with the GTK back right here, the GTKBox back start pack start, where I said false, false, and 0. Basically, it is the same like this one. At this point, we have false, false, and 0. If you set or if you call the GTKBox pack start with the button expand set to true, fill to false, which I'm going to do right now. Right here, I'm going to click this button. Basically, now it is the same like when you call this one with true. Okay, not there. So basically, now the GTKBox pack start looks like this: a button, true, false, 0. You see? Now it is the thing which we did. If I comment it out, it goes back to false, and as you can see, the button is left on the left. If I click on the fill, nothing happens. You see, and this is because, as you already noticed here, it says True if space given to child by the expand option is actually allocated to child. And the important part is this one. If expand is set to false, then this parameter has no effect, you see. So basically this is right here. So no matter what you are clicking here, nothing happens as long as you expand you don't set it to true. The padding right here, it is basically when you're setting some value here. For example, me, I set it 50. So now at this point 50 means right here we have 50 left, 50 right. This is the padding which you get, not top, not bottom, left and right. Now of course if you want to see the fill, you need to set the expand. Once that you set the expand to true, and then you set the fill also to true with the padding to 0, it will basically look like this. As you can see, first it is extending in the middle, and at least like takes the center place. At this point it's expanding, which means the left and right space should be the same. This means when you expand it. And fill means take that empty space and occupy it with a widget, with a child. At this point fill means it takes in this place. If you set the padding, let's say with a value of 50, like here true 50, I'm going to set it to 50, me because my application already was created with a 50 padding. Watch what's happened when I click the padding. As you can see, now we have 50 padding left and 50 padding right pixels. And now if you drop the expand, you see now the fill still doesn't has any effect, but you have the padding right there, see. So the fill is done. The fill has nothing to do with the padding as well, which means filling means you need to expand it. But as you can see, the padding takes place and has doesn't need the expand to be set true or false, which this is the difference which makes the padding. Now I'm setting the 50 pixel padding. And of course, again, expand means take the whole place, put the child inside in the middle of that place, so that left and right from the child should be equal the space. And of course, if I don't want to have an empty space right there, then fill it and take that place. And if I still want to do something more special, that means I need to set the padding, then you will do it like this. And at this point you see we have a padding, fill and extend, all of them set. So basically now the program which is true 50 looks like this. If we compile it and run it, our program, I forgot the comma right here, or I lost it somewhere. As you can see, this is the same thing which we did. You see, now we have the button and we have 50 left and 50 right, and this is because we set the true to expand and fill. If we set the fill to false, you will see that the button stays in the middle, and the padding you won't see it because of the window. It's too much space, so you don't notice the padding right now, but you see how it looks like. Now the same story goes, of course, if you try to pack, if you call the next function, which is to the end, which means from the right to left. If you call this function, I'm going to copy and call this function right here. And now I'm going to set them all back to false and 0. And now we are packing at the end, which means at the right side. So the button should be packed on the right at this point. I'm going to compile it and run it. As you can see, now the button is here. Basically, it is the same thing. If I now choose the expand to set it to true, now at this point, we put it in the center. You see, if we decide to fill it, now takes the whole place, even if it was back on the right. And if you set some padding, let's say 50 pixels, then it will set the padding left and right at the 50 pixels. So basically this is what does GTKBox pack start and GTKBox end. That being said, it's enough for today. Thank you guys for watching. If you like it, please subscribe, share with your friends and neighbors, and until next time, see you guys.